All right, so let's move on to distance formula, right? That's the next topic aside from midpoint. And here we're going to derive the distance formula. So how can you find the distance between P, x1, y1, and Q, x2, y2 on the coordinate plane? Well, if you look at this picture here, right? So originally it's just P and Q and this D, so all the black stuff, right? But notice that they connected P and Q with a horizontal and vertical segment, segments, to create a right triangle. And there's a famous theorem that I think you know that involves right triangles called Pythagorean Theorem. I know for a fact that in 8th grade you are taught this, so don't tell me you've never seen it. Pythagorean Theorem. It involves right triangles, so here's my right triangle. Typically, the three sides are called A, B, and C, and the Pythagorean Theorem says A squared plus B squared equals C squared. This is Pythagorean Theorem. So we are going to let the horizontal length here be A, the vertical length here be B, and our distance we're trying to find, we'll call that C. So we're going to plug in these absolute values. Now, the only reason they have the absolute value is because they want it to be a positive distance. You're going to see soon that the absolute value goes away. So we're going to do the absolute value of x2 minus x1, and that's going to be squared, plus the absolute value of y2 minus y1, and that's going to be squared. And this is going to equal our distance squared. Now, we want to find the distance. So what we're going to do is we're going to take the square root of that. The square root gets rid of the squared. So that's the purpose, is to cancel out the squared. So what that's going to do here, I'm going to put D first, is that's going to get D all by itself. Now, if you take the square root of the right side, you also have to take the square root of the left side. So we're going to put this whole left side in one big square root. And when it comes to square roots, this addition sign between this term and this term makes it impossible for these squareds to cancel. Okay, if there was only one of them inside the square root, yes, it would cancel the squared. But because of the plus sign and the fact that there's two terms, this doesn't simplify. The only thing that changes is that when you square a number, it always becomes positive, so we don't need the absolute values anymore. So we're going to get, I'll just leave it in blue, how about that? So we're going to get, in parentheses now, x2 minus x1 squared, plus in parentheses y2 minus y1 squared. But now that whole thing is inside a square root. And this, my friends, is the distance formula they want you to know. So that's our deriving the distance formula from Pythagorean theorem in right triangles. Now, in my opinion, that's a big, long formula to remember, all right? But here it is again. I am going to suggest we do something different, okay? I'm going to suggest we lean more on the Pythagorean theorem. So if I want to find the distance, I guess I'll do it in blue, between P and Q, to find this distance, we're going to call this horizontal segment of this right triangle, let's call that the length of x. Let's find the distance x and square it. And again, we're going to count that distance, so it's going to be positive. And then let's find the vertical distance here and call it y. Let's add that to x and square it, and let's take the square root of that. This, my friends, is a much simpler version of the distance formula that I think you should try to remember. Okay? So you can see they'd even do it on the picture. Look here. So they have 6 as this length. So they counted 1, 2, 3, 4, 5, 6. They have 4 as this length, because counted 1, 2, 3, 4. And now look at their distance formula right there. They have the square root. Now, again, their square root doesn't go all the way, but of 6 squared plus 4 squared. That's all you're going to do. That is exactly the same thing as what we're talking about here. Okay. Now, they will let me go to the website and mess with it, so I'm going to do that real fast. And let's see if I can make some nice numbers. So again, if you look here, if I move it to another point, and it's doing it, see, look. So now you have 5 and 7, 5 squared plus 7 squared. A typical perfect right triangle or Pythagorean triple is 3, 4, 5. So if I can make 4, 3, this is 4 squared plus 3 squared, and the square root, you get a nice answer of 5. And again, if the picture's like this, same thing. You can still do the Pythagorean theorem even if the triangle's the other way, I guess. But again, notice it's the square root of the x squared plus the square root of the y squared. So here, 5 is my x, square root of x squared, 5 squared. 3 is my y, plus 3 squared. Cool. All right, so let's see if we can find some distances ourselves. Oh, nice. Right off the get-go. Last problem is a nice word problem. Here we go from my baseball fans. So it says a pitcher throws a ball to a batter who hits the ball to the shortstop. If the ball travels in a straight line between each, what is the total distance traveled by the ball? Round your answers the nearest tenth of a foot. Okay. Now, a couple of things here. Let's first talk about the paths, right? So this ball is thrown from the pitcher to the batter. So this is path 1. So here's the pitcher. It goes from P to B. So there's going to be distance 1. And then he hits it or she hits it straight line from B to S. You see that straight line? That's pretty good, right? And that's distance 2. And we want that total distance. So we want the distance from P to B. I'll do that in red. And then the distance from B to S. And I'll do it in blue. Okay. Well, we're going to use the whole Pythagorean theorem idea. We're going to create, and I'll do it in orange here for P to B, a right triangle around PB. We're going to count this x distance. 1, 2, 3, 4, 5. Going to count this y distance. 1, 2, 3, 4, 5. And to find PB, we're going to take 5 squared plus 5 squared and put it inside of a square root. So for right now, and I'll do it with you real fast, man. No, I'll do it in a second. We're just going to do 5 squared plus 5 squared. 5 squared is 25. 25 plus 25 is 50. We're not going to type in the square root yet. We're going to wait. Okay. Now, this is units. One thing that I actually just noticed here as I'm making this video is this right down here. 1 unit is 9 feet. So we have to make sure that we convert that in the end. Okay. All right. So I'm going to write right here. 1 unit equals 9 feet. We'll talk about what that means in a second. Okay, so now let's go with the second distance from the batter to the shortstop. And I'm actually going to make the triangle up here so that it's not in the way of the other triangle, the right triangle. I'll still count the x distance first. 1, 2, 3, 4, 5. So that's 5. And then the y distance. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It started at 0 and went to 10. So I should know that that's 10. So to find the distance from the batter to the shortstop, we're going to do 5 squared plus 10 squared inside the square root. Again, 5 squared is 25. 10 squared is 100. That's 125 in the square root. That's in units. So what we're going to do is to find the total distance, we're going to add square root of 50 plus square root of 125. But then once you get this total, that's going to be in units. So then we have to take this number and multiply it by 9 feet. And that'll give us the total length in feet. We're going to do that together right here on Desmos graphing calculator. So let me get out of here real fast. Let's go to the graphing calculator, which I have bookmarked right here. Now, in Desmos graphing calculator, if you're trying to do square roots, you have to use the keyboard button. Square root of 50. I arrowed to the right, plus square root of 125. Now, what I'm going to do is I'm going to go back to the beginning because I forgot. And I'm going to put a parenthesis here. I'm going to close the parenthesis here. So that's the number of units. We're going to multiply that by 9 for the 9 feet. And there is our answer. So right now, that answer is 164.26. It says round to the nearest tenth. The 2 is in the tenths. The 6 after it makes this 2 become a 3. So the total distance is 164.3, and that would be in feet. And there's the total distance that baseball traveled. Nice, awesome, so good. So hopefully you have a little bit of a grasp on midpoint distance and can find these measurements with no problem. All right, thanks for watching. We'll see you next time.